test is independent sample t-test. In that independent sample t-test, there are two groups. I am taking class for two sections, section A and section B. Or in some of the universities, you will have a morning shift, evening shift. In Anna University, we will have a day college and part-time. Part-time means evening. Whatever be the subjects they are taking, same. If I am the faculty, I am taking in a full-time, I am daytime, so I am taking in the evening time. Whether the students will have whether the timing of or the day shift or A shift or B shift will have an impact on that. Like that, you want to measure, that time you will go for the sample t-test, the independent sample t-test. We are comparing two means. At a time, we are comparing two means. In that independent sample t-test, you will go to the data set. You will, there are two means are there. Here I have two batches score I am taking it. So I will say that my group A, group B, or batch 1, batch 2, section A, section B, whatever way you want to name it. So I have a group A, group B, A section and B section. I have two sections, A section and B section. So I made it in the group. In the value labels, I mentioned it. Okay. Somebody has a doubt, you can get into the help of YouTube videos, or you can call us. We will help you out how to key in the all those things. Okay, fine. At present, you can, if you are not confident, you double click it. The SPSS file will be open. You do the analysis. Okay, fine. So one item normally generally will be nominal or ordinal. Other item will be scale item. So scale item has to be done. Okay, fine. So here I am entering it. Whatever be the group 1, section A, these are all the section 1 I mentioned, their marks are have been entered here. Section B, the marks are entered here, my subject. Now I go to the analysis, the performance wise, anything is difference is there. Then I will go for compare mean, independent sample t-test. And one more thing I want to mention it here. We will reset. Here you can see that in a group 1, I'll be having it 40 students. In group 2, I will have only 32 students. So in reality, you can see that all the groups will not have the same numbers. In the morning batch, many person will be there. In the evening batch, numbers will be varying it. So A section, B section, you have a why it is nominal. A section, B section doesn't have any specific impact. Whether you are in A section or B section, both the things will be there. A is not superior, B is not inferior, not like that. Only thing is if it is a considerable thing that I will be go there. It is nominating, just you are nominating. So why you are going for nominals? I have a larger group. I want to manage. In order to manage the larger group, I am making into small inference. You cannot able to. I say that A section, B section, C section. You cannot come to any inference on that because in my admission, first person A section, second person B section, third person C section, fourth person again A section. Like that, I am putting it. It doesn't not anything. I have 180 students. In order to manage that 180 students, I am putting into 60, 60, 60. Like that. Okay. To handle the larger group, making it. A, B, C is just for identification purpose, nothing else. In other words, it has a meaning. Scale item means it has a meaning. Okay, fine. So we'll go to the analyze, compare mean, independent sample t-test. So the test variable always will be scale item. I repeat, go to the analyze, compare mean, independent sample t-test. Somebody want to make a note, can make a note. Analyze, compare mean, independent sample score. So grouping variable I am giving it here. You can define groups. If suppose somebody will be giving group values in your value labels, zeros and ones. Somebody will say that zeros and ones. Yes, no type you can use it. Oh, yes, no type. Yes means 1, no means 0. Like that you will say that. Okay, fine. So here I have been grouped as a 1 and 2. So in define group, I will say that group 1 is 1. group 2 is true. So I'm doing it. Suppose if you are using zeros and ones, you have to do it as a zeros and one. Again, you click options, you can see that by default it is 95%. So I repeat, analyze, compare mean, independent sample t-test. We will get the test window. In the test window, the test variable will be test score and the grouping variable will be here. Then I have to define group. Whatever they are doing, giving it the group. If zeros and one, I will give zeros and one. In my case, I given as 1 and 2, so I am using it. So now I am clicking OK. Independent sample t-test output. This is my independent sample t-test. So equal variance is assumed. Equal variance assumed, whether not assumed. Sir, which one I have to take it? Again, it is the researcher who has to do it. Suppose I want to compare two students. One is in a city, two group of students for the same subject. One is in the city, another one is in rural. That time, the variances are not same. Definitely, the equal variances we could not assume. If I am the person taking section A and section B and same college, same thing, same hours, same working time, if that is the case, it is better to go for equal variances. You have to assume that the variances are equal. Okay, fine. Here we are doing it. We have find out the t value is the calculated t value is 3.390 and the significance value is 0.001. It is less than 0.005. So we are rejecting the null hypothesis. So here, as I said that mu1, mu2, both the population means are same. There is no significant difference. So there is no significant difference with respect to group or section. But in alternate hypothesis, there is a significant difference. Okay, fine. So in this output, I'm seeing that, okay, whether it is a significant difference. Okay, fine. There's a difference. Okay, fine. So if there is a group A and group B, there is a difference, is the performances difference is there. So which is doing better? Obviously, that question will rise. Sir, you are taking two sections, section A and section B, or the performances are same. I'll say that no, that there is a significant difference. Okay, fine. So which section is performed well? There I will go and see the mean value. So here the group A mean is 63, group B mean is 51. The mean, we are comparing the mean, whether there will be always the means or difference. The difference, whether the difference is significant, insignificant, that's why we are testing. So the group, it is significant. So group A is doing well and better. So this is how you can able to interpret the results. Okay. Next we are going for paired sample t-test. It is like same as one sample t-test. In one sample t-test, we have been collected data only once. In paired sample t-test, all the whatever be the sample, whatever be the respondents, overall the respondent, whatever be the sample, we have been collected one time. Again, one more time, we are collecting from all the same persons. If that is the case, it is a paired sample. We'll say that paired sample. So for training program, exercises, generally diet programs, administration of a drug, these are all the cases. What will be the impact? What is the time? So we will go for before and after, like that. We will go for before and after. So the hypothesis, we are giving it before and after. So for that, we will do the analysis. In that analysis, we will have a paired sample. In that paired sample, we will have a before and after, both the things will be thing. In this case, before and after. So suppose in independent sample t-test, you can give any order. If the person 5, sample is 5, what is before, what is after? It has to be matched. Before and after should be matched for the same persons. And it has to be matched so that your total response for before and after should be same. So this data will be compared with this. This value is compared with this. This value is compared with this. Like that. The mean is making it, and the mean is compared with this. Okay, fine. It is better always not change the order. Okay, fine. Analyze. Compare mean. Compare mean. Paired sample t-test. Paired sample t-test. You will get like this window. I repeat. Analyze. Compare mean. Paired sample t-test. I will say that before. Say that before, after I'm sending it. Okay. Before and after I'm sending it. So you are clicking work it. You will get a output. You will get an output. Okay, fine. Now we are getting it. Okay, fine. So your t value is minus 5.070. The significance is 0.000. So here the H0 is rejected. So there is a before and after, whatever be the program, if diet program is having an effect. The training program is having an effect, whatever be the case. So my special classes, before special classes and after special classes, there is an effect. So here we have been given two outputs. You can see that outputs, paired sample output. So I'll paired sample output. Word document is there. Before special class, after special class. One more, whatever things you are seeing is this second page output you are seeing it. In the second page output, you will see T value is negative. In the first page output, T value is positive. Again, you can measure, you can see that here the means 50 and 60, here the means is 60 and 50. I'm changed it. So before and after, I'm understanding purpose, I will change it. If the T value, whatever be the getting, your T value is negative, then it has been, the values has been increased. If I'm saying that my special class, my objective is the score, it has to be impact, it has to be increased. Suppose if you are doing your heart rate, pulse and all those things, the body mass, you are saying that for diet plan, you are doing your body mass, all those things. There are 40, 50 people are there. They are coming for the diet program. Initially you are saying that we are measuring the body mass. After the diet program, you are measuring the body mass. That time, it has to be impact. The diet program has to be impact. If that is the case, the body mass has to come down. Already they are overweight. Their body mass BMI index is very high. They want to make it to the normal. So it has to come down. That time the T value will be positive. If before and after the value is increased, the average is increased, or performance, the measures are increased, the T value will be minus. After the measure value is decreased, the T value will become plus. This is the only point I want to make it out here. So paired sample t-test. There are two things. You will say that whether the null hypothesis is rejected or not. If you are able to reject, then reject. You go to the alternate hypothesis. So based on that, whether it has been a positive impact or negative impact. Based on your research problem, you will get plus T value or minus T value. This is how you are doing it. Next, we are going for ANOVA. This is the only, sir, we have been dealing with only two means. If I have more than two means, what I have to do with that? You can do multiple. If I have four means, A, B, B, C, C, D, A, C, A, D, like that you will do pairwise comparison. If that is the case, each and every time your confidence level is 0.95, 0.95, 0.95, you are multiplying it. What will be your confidence level? It comes down to 0.6, 0.5. 50% confidence. If you are saying a result, what is the confidence level of saying that? If I am a manager, you are coming and you are saying that 50% confidence. No. Confidence has to be higher. If that is the case, we are going for ANOVA. In ANOVA, mostly, majority of the time, it has been developed for field experiments. You can see that statistics, they will say that field experiments. all the experimental designs, mostly experimental designs are using for going with the ANOVA. If you want to know the rationality behind that ANOVA, I want to study, sir. My research is mostly, my research tool is ANOVA. I'm not going for SIM and all those things. I want to have ANOVA. Mine is experimental design, like that. So I want to have what is a correction factor, what is total sum of squares, what is the error sum of squares. So individual things between sum of squares, all those analysis I want to make it. You want to have, these are all the things, details, so that I can able to break down my analysis. I will get more output from my analysis. For that, you have to go for a design of experiments by Montgomery. There, they have been given analysis of ANOVA. And one more thing, applied design of experiments by Krishnaya sir and Sagavuddin sir, they have been written. I studied that book. When I was in the PhD, I had taken design of experiments as one of my PhD coursework. So I've been used that book, Montgomery book. It is a very huge content of that. I want to have a crispy and practical things. I gone with the design of applied design of experiments. They have been made into application oriented. As management guy, why I have to go for so many things? So I'm going for, I've been tried for experimental research in social science. So there I found the control variable is very difficult. How I have to do it? Now you can control variable, make it as a gender, age, income group. Like that you can, the demographic variables, make it as a control variable. That I've been learned things. So the time doesn't permit. So I gone with the but cross-sectional study. Instead of going for experimental design, I gone with the primary data. I will do it done like this. So if you want to have ANOVA detailed things, sir, I want to have my studies, everything, go for design of experiments, Montgomery or Sagavuddin sir and Krishna sir who have been written. Sir, we don't want that much of things. Whatever things we know the management perspective, that is enough, sir. You will better go with the one way ANOVA, we better go with the Levin Statistics for Management, Levin and Rubin. That book, whatever things explanation they are given, that's more than enough. Still, you want to go for MONOVA and all those things. That's multivariate techniques. You can use multivariate data analysis by Air, Black, Tatum. That book you can use it. That is one of the good book. Many of you would have been referred it for your PhD and research paper writing. Air book you can use it. Okay. So in that ANOVA, we are going with measuring more than 2 minutes at a particular time. So here I am taking it subject 4 subjects, whether the same the students are doing are different 4 sections on a same subject, or 4 persons, same person, 4 subjects, like that I am taking it. So the subject, I will have subjects. 4 subjects, subject A, subject B, subject C, subject D, like that. And the test scores are there. That I have been entered. You know, suppose I'm running an elective subject. May not be all the persons will be the same elective. Maybe some colleges we are giving it, all the persons has to take it. In some of the colleges they will say that their choice. In a finance paper, particular paper, 60% persons were registered. In other paper, 42% persons will be registering, like that. It will be like that. So whether we want to see that all the finances papers are giving it the same score, like that, we'll have a 4 minutes. For that, we are going to compare all those things. Sorry, excuse me. ANOVA. The same way, analyze for double ANOVA table, ANOVA file. You will get this screen. Come to this screen, analyze. Again, we are comparing the mean. So one way ANOVA. Compare mean. Sorry, one way ANOVA. The thing is, dependent list is a test score. Factor is here. Then you can go for options. You can see that if you want to describe whatever things you want, you can take it. So it depends on the research, what are the output you want to do it. You want to do a fixed effect, random effect, like that, you can do it. Sir, I want homogeneity. I want to see that my research problem is most on that. You can do it. Sir, I want the plots. Based on the plot, I want to make interpretation. You can choose it. So otherwise, I will go for a post-hoc. Only thing is there are many post-hocs are there. So whichever be the post-hoc test you want it, then I will see that what is the significance level. 0.05. This is enough. I will give. For me, it is enough. I give okay, then I will go to the output. So I will get descriptives, ANOVA. I will see that. So here what we see that H0 is mu1, mu2, mu3, mu1 is equal to mu2 is equal to mu3 is equal to mu4. Like that, if you have how many number of means are there, it equal to mu1, like that you can have it. The alternate hypothesis, actually, one of the thing is not, mean is different. It means mu1 is not equal to mu2, mu2 is not equal to mu3. Need not be all things. Any one is enough. Like that. So, what all the groups are different? I want to say that. Is there all the means are same? No, it is not the same. The significant is 0.003. So, all the means are the same. So, we are going alternate, accepting the alternate hypothesis. In that alternate hypothesis, I will go to the post-hoc test. I've been choose it. Here, what are the things we say that? Definitely, mu A is not equal to mu C. Mu A is not equal to mu D. I will say that mu A is not equal to mu C, mu A is not equal to mu D, like that. You can interpret whatever the information you need, what kind of problem you can interpret like this. This is the ANOVA. Till then, any doubts, you can ask that. We will move on. If no doubt, then we will move on to the regression analysis. T-test, ANOVA, if you have any doubt, any of the persons, let me know. We'll try to give our inputs. If no doubts, sir, Madam Sindhu, madam, range below 40, 50. Whatever way we are having it, actual data we are using it. So whatever things I've taken it, whatever the data set is available for me, I'm using it. If you want a group, you can go for group. You have the groups, you can do it in the descriptive analysis. Groups, you can form it. If no doubt, then we'll move to the regression analysis. In the regression analysis, we are finding out, before regression analysis, normally people will do the regression. When you are going writing a research paper, you will do multiple regression. So why we are doing multiple regression? In order to avoid redundancy, capturing redundancy, and all that, we are doing a pilot study. In the pilot study, we will run a multiple correlation analysis, which are all the items are highly correlated, we will avoid, because we are same thing we are measuring 2 times. So same thing we are measuring 2 times. So in order to avoid all those things, one at a time is enough. So we are going based on the what are the regression analysis. We are saying that based on that we will do the cross-sectional study at one point in time. We will have a time series regression. If cross-section and time series are there, we will go for panel data. So for cross-section, normally what we will do, SPSS, almost SPSS is more than enough. For time series, whatever be the software package available, you can do it. Widely, generally used in the education community, the researchers, we are all doing it in e-views. Sir, I want to do FreeVS, you can use R package, or you can use Gretel. Those packages you can use it. Why? Because in time series analysis, some of the books are there using it. Previously, they have been used SAS. Now they are using Damodar Gujarati books. Also, they have been used it using econometrics by Damodar Gujarati book. They have been one of the version has been given on used Gretel, and the Gretel data sets are given on that. Okay. based on the number of explanatory variable, we will go for analysis. Based on the relationship, we will go for linear, and we will go for non-linear. Normally, generally, in educational analysis, we will go with the linear relationship. On paper writing and all those things, we will go for linear relationship. If you have your research problem really needs literatures are available, many books are available to deal with the non-linear regressions. Okay. So in a simple linear regression, we'll have two variables been related with. One will be independent variable, another will be dependent variable. One is explanatory variable, another one is explained variable. So how we are using it, what context we are using it, based on that, the y and x are being it. So normal general we say that it is y is dependent variable, x is independent variable, y is explained variable. You can use it, whatever we have used it. So we are writing in a straight line format. It is a thing in a simple linear regression. We say that y is equal to a plus bx, or y is equal to mx plus c, y is equal to alpha plus beta x. Whatever way you been comfortable, you use that. The only thing is the intercept and the slope. Here the slope is, in a simple regression, the slope is nothing but your correlation coefficient. Slope is your correlation coefficient. So in dependent variable, the x variable are the independent variables are more than one, we will go for multiple linear regression. So once I've been started using more than one variable, always there is a chances that they more than higher orders are there. The higher orders in experimental design, they will say that it is an interaction effect, first order interaction. If I have a third variable, so x1, x2, x3, normally generally we will build a model as y is equal to a plus b1 x1 plus b2 x2, like that bn xn. We are building like models like this. But indirectly, there will be b n1 x1 x2. That variable is also there. Okay, we will see one by one in our analysis. So we'll go to the. So for regression analysis, with the permission of Dr. Murugan, I am using that is a data set. This data set, and that paper also given what has been written. The first paper it has been written by him is test of greenhouse and all and model on work family balance, work-life balance, work-family balance, like that. That is what is research. He has been added this as one of the chapter in his PhD thesis. So he has been published this in current psychology. So whatever the data set he has been used for writing this article, we are using that for doing model for regression analysis. Okay, fine. So that model is WPF. I have worked on that. WFTP. I have a full set. For you, may not be having a full set. I may delete. Yeah, I have deleted here. 2091 will that. His sample size is more than that. What are things we are having it enough? So here you can see that is for job satisfaction. We have been made it 3 construct. So all these things you will, when we are doing for regression analysis, we will have converted into only JS, like that, job satisfaction or family balance, family satisfaction. So the output variable is the life satisfaction, like that. So which has to take, it depends on you. How you are defining which is the independent variable, is a dependent variable. It is based on that. You have to decide that. Suppose I am saying that life satisfaction is function of family satisfaction. Life satisfaction is function of family satisfaction. Okay, 1 minute. I will open this paper. I will say that I will be taken only this. Life satisfaction is effective variable, and work family balance is independent variable. Work life family balance is leads to life satisfaction. It means work family balance is explanatory variable, which is explaining life satisfaction. Like that, I am taking it here. So remaining is for doubt for a simple linear. So life satisfaction is equal to function of work-family balance. So here we are going there. This is the data set. Life satisfaction is only function of work-family balance. So how to do the analysis? So in that analysis, I will go for 1 minute. Analyze comparison. Regression linear. So simple linear means you put one variable. So my thing is life satisfaction in descriptives. Okay. We'll say that there are it should be there are many conditions for that. You can go to the book. You can see that all the things. In conditions, you can see that. Okay, fine. For MLR, you can use multivariate data analysis by hair, black, all those conditions they have been given, all those things. In multivariate, what are the assumptions it has to fulfill? The data set has to fulfill. Okay, fine. Okay, I will give continue options. I'll see that. Okay, continue. Then I will give. Okay. So I'm getting it. These are all the things. Descriptive statistics. I'll click the correlation. I'm getting it here. Normally, the model summary. These are all things this even descriptive statistics is not there. If you are not getting it, okay, fine. At least these 3 tables you need to get it. At least in order to give some interpretation, you have to get these things. Here you will have a model summary. In the model summary, you will have R value, R square value, coefficient of regression. Its coefficient of regression is equal to R square value is equal to explained variance by total variance. Here, I will see that the R square is 0.248. Or adjusting with the degrees of freedom, I will get 2.244. The maximum R square value is 0.1. In some of the rare and rarest case, the adjusted R square, you may get negative. Rare and rarest case. Okay. That you can refer the, sir, what kind of case I want to learn all those things, refer the hair book, there it has been clearly explained. Okay, fine. Rare and rarest case, adjusted R square will be there. Here I'm seeing that. So, dependent variable is life satisfaction. In coming to the ANOVA, I'm saying that this is significant. This variable is significant. The predictor work family balance is significant. Now I'm saying that it is significant. So it is explaining the work family balance is explaining life satisfaction by 24.4%. This is how I can make the meaningful interpretation. If a manager or somebody is saying that, okay, you found that it is significant, how much it is significant? How much it is explaining? It is explaining this explained variable. Okay, it is explaining 24.5%. If you are taking care of work-family balance, your life satisfaction will be 24%. You will achieve your target of 100% life satisfaction, you will achieve 24%. So what are the remaining? There are remaining items for that. Here we will say, write the equation with the coefficient. Here the equations will be 3.5, y is equal to 3.50 plus 0.389 beta. Here 3.50. If you want to have an estimating equation in simple linear regression, in estimating equation, y is equal to, based on our value, this coefficient, we are getting it. Here, it is 3.530. It is a constant. It is nothing but our intercept. 0.389 is slope. Okay, fine. 0.389 is slope. 3.58 something plus 0.389x. This is what our estimating equation. Estimating equation. Suppose something one predict. For an example, I'm giving a some test. I'm running things in the test. So what will be the probability that person will score in the examination? This is what I want to predict. I'm running a special course and all those things. What is the support for that? I will have things. What will be the exam score? You will get it. Previously, we will be run based on that. We will have estimating equation. We will put this thing to that equation. We will find out what will be the result. This is how we are doing it. Next, we are going to the MLR. So I will put all the variables here. You can see this paper, Murugan paper. So you will use this job satisfaction, family satisfaction, WFB. Three things will be there, life satisfaction. I'm going and using it all those things. I will go to the analyze, regression, linear. I will reset everything. So my life satisfaction will be the effect variable, dependent variable. All the things variable will be independent variable. So here the method is there. So normally the method is enter method. The method is enter method. If you want to do stepwise regression, you can use add by. Okay, you can use it like that. Here I can use that Durban. Here I say the descriptive. I will take it as a Durban version. So in maybe social science we are not given much of the importance for Durban Watson statistics. If you are doing it in a yesterday's session, data sets which related to what Murugan has said on yesterday's session, if that data sets you are dealing with that, you have to take care of Durban Watson statistics. So we'll go that option. We'll see that. Okay, fine. Continue with the options. Okay, fine. I'll click OK. So these are all the things I'm getting a descriptive statistics, correlation, things. Now I'm getting it. So this R square, I'll say that the model is significant and all those things, the R square is increasing. Whatever be the variable you are adding it, R square is significant. Okay. Now you see that this T value, the coefficient, you see that dependent variable is life satisfaction. So here I'm saying that significant is 0.128. Here in our simple linear regression, we have been made it work family balance. It is significant for life satisfaction. Okay. But I'm adding job satisfaction. I'm adding these two variables. Work family balance, I'm adding the job satisfaction as well as the family satisfaction. The individual effect. Here we say that it is the individual effect is become insignificant. The individual effect will become insignificant t-test. But the remaining two, job satisfaction and family satisfaction, are significant. So if that is the case, there will be an interaction effect. There will be an interaction effect. That is, in social science, the interaction effect is called as moderation effect. That interaction effect in experimental design, that is interaction effect. In social science, we are saying that is the moderation effect. That is the moderation effect. So whether I have to, if that is the case, if you have a first time you are saying that, first time you are reading it, your multiple linear regression is having a things. Multiple linear regression is having initially 5 variables. Again, you are adding one more variable. Whatever be the variable you are adding it, whether it is significant or insignificant, the R square will tend to improvise. Or we'll say that R square will be tend to improve. It is the researcher who have to say that whether the insignificant variable you have to keep it or not. In order to have a clear idea whether it has been the moderation effect, the interaction effects are there, whatever be the model, if I'm saying that here the model is, I'm saying here in the multiple regression model is y is equal to 0.154. In the multiple regression model is y is equal to 0.1 plus 0.57, 0.257 work family balance, 0.57 work family balance 0.257. I don't know. So things 0.257. Job satisfaction, 0.597. Family satisfaction. Okay. Job satisfaction plus 0.597 family satisfaction, like that. Okay. So this is what my estimating equation. I want to say whether this is estimating equation is holds good or not. In order to confirm that, we will go and see Durbin-Watson statistics. This is they're done in a seminal work. It is widely used. One of the major threshold criteria you have to report in time series analysis. In social science, normally we won't give much importance for Durbin-Watson statistics. The threshold limit is the Durbin-Watson statistic value has to be somewhere around 2. You will not get exactly, you will not get 2. It has to be around 2. In our analysis, we are getting it 2.034. Okay, fine, good. So we have to keep this insignificant variable. Suppose it is not there around, it is 1.6, 1.5, 1.4, 1.6 like that. You have to add some variable, or you have to remove insignificant variable in order to improve the exact model. You may be not exactly identified model. You have many unnecessary variables you are keeping in your model. These are all the ways you can be able to have interpret in your results. So again, we are saying that in simple linear regression, this 0.389 will be your simple correlation coefficient. Here, it will be 0.57, 0.257, 0.597. These are all partial correlation coefficients. You can have some of the inputs, some of the information I have to make it, some of the inference I have to make it in my study. I want the partial correlation coefficient. That time it will be partial correlation coefficients. It all things. So in your independent variable is scale item. Suppose it is not scale, not a metric data. It is not a scale. It is not a scale item. You will have groups like that, 40 to 50 or like that. That will be that kind of things. You can, if you are doing this kind of MLR, you will have you will not get the results. You may get results, but the results will solve your intended purpose. That is the question mark. For that, we are using logistic regression. That will be handled by our HOD madam on tomorrow's session. Logistic regression. Madam is spending one thing. If you have any queries or any doubts,